Great. Okay. So, currently, for everybody who's taken the exams, and there's a number of people who haven't, first off, if for some reason you've missed the exam and not reached out to me or your TA to fix this, you need to reach out and fix it. It's your responsibility to basically find a time to take the exam if you missed it, right? And find a time to come in, okay? Don't be passive about it. We've got a case of a student like saying, well, we're trying to figure out when it works for them, and they're like, well, I have class during this time. How do you have class during our lab? Regardless, point is that you got to understand that for making up this exam, I am being extremely lenient here. We are well within our rights to say, it's too bad, so sad, we're going to drop, it's best 2 out of 3 anyway, so you just have to take the third exam. But we want you to have the opportunity to take this exam if you missed it because of health issues or because SEPTA's been just messed up. You know, there's been a lot of issues with SEPTA recently, with the trains, fire and like that. So we're just trying to make sure that everybody gets the chance. So if you didn't take the exam for some reason, be it illness, that's perfectly valid, because SEPTA decided to ruin your day in particular, just send us an email and get in touch with us. That has happened with a number of students. They've reached out, they've done what they need to do. I'm just saying if you haven't, do so, okay? Now, with regards to where we are in the class with the actual exam grading, we've graded most of the exam. I piled all the TAs into my room a couple hours ago, and we've been grading. We will either have depending on how many TAs are able to resume grading with me because we have like only one question left to grade in across the entire all students. Depending on how many TAs I'm able to pile into my room with me, you'll have after this lecture, we'll either have the exam grades out to you on Tuesday or Thursday. You can pick up your lab and you can pick up your exam when you are in your lab. Now, a couple of notes on your grade. First off, we're human. Check to make sure that I know this sounds silly, but you want to check to make sure we didn't make an addition error, right? This has happened before where I've been 10 points off on adding up a student's grade, and they needed to be, and they were missing an entire letter grade, right? They had I wrote, they had like a 74 and really should have been an 84, right? Because I count bad or something. We're human. We make mistakes like that, okay? So just be aware, don't be afraid to come up and say, hey, you made a very simple arithmetic error, because we're trying to do this quickly so that we can get it back to you, right? That happens. It's rare, but it does happen. Don't be afraid to just come up to us. Those kind of things we're good about. Second, when we are grading, I try to tell my TAs to be a bit stricter on grading. If they aren't sure whether to get if you get partial credit on a 5-point problem and they're unsure whether they give 3 or 2, I say err on the side of 2 because it's always easier to give you the points back. It's very hard for me to take them away once I've given you the exam, but I can always give you points back. So if you feel like that's a long-winded way of me saying, hey, if you feel like you earned more points than I gave you, right? Earned more points than I scored, or I missed something that was relevant, right? Again, talk to me. Okay, I'll be happy to give you, I will humor you, okay? And yes, I do give points back to students, okay? So please, just, if something on your exam needs to be corrected, please let me know. I want you to get the grade you earned, okay? Okay, now with that being said, yes?
You said, pick up our exam, Tuesday or Thursday. You mean next week?
I'm saying in your your grade will appear on Canvas on either today or on Thursday, depending on how many TAs are able to come back and meet with me after the lecture. We will then you will then go through, enter the grades, unsort the exam so they go back to the appropriate sections, and then you can pick up your exam in lab, right? If you,
what about during my TA's office hours?
Yeah, you can totally get it during your TA's office hours as well. Yeah, your TAs will have the exams, because I've tried handing the exams back in class. We'd just be getting started if I had started at the beginning of the lecture. It takes forever. It eats up a lot of time to just try to hand back, and a lot of students don't show up to the lecture. I mean, you all did, so you're great. You're great. All right. So the good news is that you are like a few weeks away from calling yourself a programmer, I would say. You've learned for loops, currently learning how to master them. You're currently working on while loops. And I will address that homework in a bit, but you hopefully will have gotten a notification today that I've pushed some homeworks back. I'll talk about that in a minute, okay? But the homework that was due tomorrow is now due Friday, okay? Same with next week's homework that is due Wednesday. That is also due the following Friday. So those due dates have been pushed back. I might push some back further, depending, because I'm thinking about taking that last homework and making it an in-class exercise and swapping out something a bit different, just simply to put a bit less pressure on everybody, because it does feel like we're going a bit faster than this class is maybe comfortable with the homework. I don't know. I'm not sure what's up this semester. I feel like I've got still got a spread of students who get it, a spread of students who don't get it, and that's normal. But I just want to make sure that as many students do get to the point of getting it. So that being said, after learning for loops, while loops, if statements, we basically have two things for you to learn before I can basically say you should be able to call yourself a programmer. The first is what we'll be doing in Lab 7, which is being able to interact with things outside of your program. That's the first thing. And I'm going over both Lab 6 and Lab 7 today. Normally today I'd be doing the file reading lecture, and I might get started with that, depending on the amount of time I have, but I want to make sure I take this time to get this established for you guys. Then once we're done with Labs 6 and 7, the last thing I would say is learning dictionaries, or hash maps, or hash tables, or associative arrays, depending on the language that you're working in. And in Python it's called dictionaries, but they are efficient key-value pair storage. They're the other tool, right, that you would use to do data storage and retrieval as opposed to a list. And they're very powerful and very useful. So just want to make sure you have those things. So let me go ahead and pull up Canvas. And we're going to talk a bit about part of problems of Lab 6 and a bit and then I'm definitely going to go over Lab 7 because it's got that intimidating, large size text I put in, right? And that large size text is actually more me yelling at bad students from the past. A particular type of bad student. I was a bad student, but I wasn't that kind of bad student. You see, you'll have to remind me to post my transcript from university, but I was pretty terrible my first 2 years of being a university student. It took me until junior to get a handle on college. And once I was in a handle of college, I had a handle on it. I was hitting Dean's List every semester. But it took a while for me to get there because I just didn't know how. I just didn't have the higher order executive functioning, I guess, the planning that I needed to do. Okay. Also, just kind of a interesting, and that leads me to just one of my few asides I want to point out to my students. And the students who work in sports therapy can actually attest to this. So, I've worked with a lot of people with ADHD. I know a lot of people who have ADHD, right? And so doing ADHD's kind of research, or not research, but reading what research has been done on it is very interesting to me. And one of the things that is tough is that if you don't get diagnosed with ADHD as a kid, it's hard to get diagnosed as an adult. That being said, strategies, non-medication strategies, are not the primary way to treat ADHD. Let's just get that out of the way. Medication is the primary way to treat ADHD, but there are strategies that can help. So one of the studies I read was on the effects of that exercise, right? Exercise, universally, doing that exercise before an activity that requires concentration helps universally, whether you are in the control group where you don't have where you are undiagnosed with ADHD, students who are, or people who are diagnosed with ADHD but don't have medication versus people who are medicated with ADHD. Yes?
Did I leave single keys around here?
Quite possible. Go ahead and take a look around.
Like yellow letter? Good.
I don't
didn't want to put. Nope. Okay. Nope.
But long story short, they found that exercise had the greatest benefit for the students who were, for those who were asked to focus on activity that were unmedicated and diagnosed with ADHD. That had the greatest benefit for them, but exercise was basically universally shown to basically help increase concentration when you did an activity right after that. Okay, so that is one of the small hacks I can at least tell you, and it works for everybody if you are able to get, and by exercise I mean just get your heart rate elevated for about 5 minutes. Okay, so that is basically the hack number 1. Hack number 2, you gotta understand that Murphy has it out for you. That's Murphy as in Murphy's Law, right? Whatever can go wrong will go wrong. If you have an exam scheduled for a Wednesday, make sure that your studying is done Monday, right? Normally you think, okay, I'll try to do my studying and might cram a bit the day of. That's personally never worked for me. It works for some people and that works for you great. But that being said, I tried to, I would try to get studied, again, exam Wednesday, try to get done studying on Tuesday. I found that stuff would inevitably happen on Tuesday, right? Something would go wrong on Tuesday and it would force me to basically have an unoptimal time studying. So, have everything done on Monday, things are going to go wrong on Tuesday anyway, and if they don't, great. I've got a very easy day to relax before a stressful day. But the number of times like stuff has come up and like my wife, who was then my girlfriend, wanted to do things on the day before scheduling an exam, that became very useful. Okay, so those are kind of hints I have for you, at least for just being able to help. But again, I was not a good student, and I just want to try to help you be the best students you can be, not just in this class, but in other classes too. Okay? Now, this was Module 6. Okay? Module 7 is sequences and file readings, but we are going to talk about the Lab 6. You'll notice that I kind of do not have anything like talking about what we're doing this week, because generally this week is a bit floaty. It's a bit trying to figure out what are we actually doing. And I do want to take that time to review Lab 6. So again, for Lab 6, you had the option of choosing which one to do. Did you want a more comfortable exercise or a less comfortable exercise? I feel like with Mario, right, first off, if you check off Mario, we do have yes, it's in another programming language for the walkthrough, but it's still fairly straightforward to follow on how to do it. You want to use a while loop to guard your entry, basically say, hey, while this is occurring, please, while you don't have a valid answer, ask the user again for a valid answer, okay? And then print out this tick mark thing, okay? That's not what I'm going to go over right now. If you need help with that, I'm more than happy to. What I find students really need help with is the cache problem, if you decide to work on that one, which is a classic one, which is given a number of cents, given money in cents, okay, how many coins need to be returned? I don't care what types they are. I just want to know what is the minimum number of coins to be returned. Right, so if I'm asking for change for 100 cents, you're going to give me 4 quarters back, 4 25-cent pieces, right? Okay, so now this is made up of essentially 2 parts, as I say, where we have an is float a function to tell if something is a float. Yeah, assume. Yeah, we ask that you assume the user will be inputting a float. However, you will need to create a function to detect whether a given string is a float or not. And this is what I'll be going over today. This will be used to validate your input. So input validation. This is what I want to tackle today. So let me see. Do I have Geany installed? Not Geany. Geany. Yes, I do. I'm just going to go ahead and pull this up because might as well get you used to the idea that people work in different apps. Wait, is it installed? Come on. Oh, yes, it is. There we go. Okay. Right, so that was Game of Life. Okay. So we'll go ahead and do a new one. So this will look both very similar and very different. It's just a different text editor, and I'm partial to it because it's very minimalistic. But it should be able to work just fine for you to follow along. Okay. So let's go ahead and create a desktop coins.py file. All right. And I want to work now. I'm going to go ahead and just kind of create a main function over here. Okay. Just kind of, I like to break down these problems in terms of outlining it. Main, and I'll just call the main function at the end when I'm done with it. And what does the main function what is the main function going to do? The main function is going to ask the user for the input. So let's go ahead and do that. Text is equal to input to do enter input text, right? I'm just good, whatever that's supposed to be, right? We're going to ask the user for change and whatnot, but that's not my job. That's your job, right? This is the easy part. And so we're going to get the user's answer. Then what we need to do is check if it is a float. If not, we could do one of two things. We could crash the program or exit out, or we could do the more fun thing, which is, if not, ask again. And then what we'll do is, then we'll tell user how many, tell user min number of coins to make change. Okay, so to do, enter the input text. Ask if it is a float. If not, ask again. So how do we do that? Well, let's go ahead and assume we've already written a function. We're going to need to write a function to check if something is a float. So let's go ahead and write the function, kind of, sort of, and pretend that it works. Okay? It's not gonna, but let's go ahead and write it. Def is float. It's going to take in some text, and it's going to check if that text is a number. And just so that we can write the rest of the program, I'm going to assume that everything works. I'm going to assume that no matter what, it is a float. Make sense? Even if that's wrong. Just so I can continue on. Okay? So let's go back to main. And this is the great thing about being able to do functions like this. You can make things and say, oh, I'm going to pretend it works. And then work on another part of the problem. Being able to break down a problem like this is invaluable. Okay, so we're going to check if the user if it's a float. So this is where we get into a while loop, where a while loop can be very useful. Because it allows us to check something again and again and again without having to specify the number of times I'm going to check it. So I could say and while loops look exactly the same as if statements. I could say if, right, not is float, right, text. And that would check once if the text was a float. But if I want to check it an unlimited number of times, I just would do this. While not is float text. So another way to write this is I could say while is float text equals false. Does that make sense? Right? Two ways to do it. I could do a not, which flips true to false, or I could say while the answer from this is false, which probably makes more sense if you're just starting out. So while the answer I get back is false, I'm going to keep I'm going to ask them to do it again. And honestly, this is actually, once you see this, you're going to be like, oh, that's easy. It's really easy. How do I keep asking them again? Well, I've already asked them once, so I'm just going to copy paste that in. So while it's not a float, I'm just going to go ahead and ask them again. Okay? I'm going to make it very simple for me to just test this. If text equals A, return false. Make sense? This is, again, not correct at all, but it allows me to test kind of this logic. And then print done to just simply say that, okay, I'm out of the loop. Make sense? So I'm going to go ahead and run this. So to do, enter input text. Okay, and I'm just going to say A, because while I hit A, it's going to return false, right? That's what I said for the function. Let's go ahead and see that function again. Is float. If text equals A, return false. So if I hit enter so if I type in anything else, literally or figuratively, it's going to exit out of the loop. It's going to say, oh, well, it wasn't an A, so I return true. And once it returns true, we break out of this loop. So everybody see how this kind of input guard works? It's saying, hey, we're going to try it. And if the user enters something sane the first time around, we're just going to be done. Make sense? The while loop will run anywhere between 0 to infinite number of times, depending on what the user enters. And then what we'll do, and then we can tell the user tell the user min number of coins to make change. Right, we can tell the user the number of coins they need at a minimum to make the change, and that will be there. Right, that's its own part of it, and we'll do that in a bit. Let's focus on now actually making this text work. So how can we tell if some arbitrary string of letters and glyphs and stuff is a floating point number? Well, let's ask ourselves, what would be valid floating point numbers? Or at least what is valid to convert to a floating point number? Okay? What can I validly convert? So something like 2.5, 2.5, right? 2.5, that's a floating point number. Okay? 2 could be converted into a float by the floating point, even though it's technically not got a floating point. I can throw it into the float function, right? So let's think about things that I cannot convert into a floating point number. Okay? The word apple, for instance, that cannot be converted into a floating point number. And the expression 9 plus 12 can't be converted into a floating point number, right? I can't take this string and convert it into a floating point number, right? Right? Because floating point, and so let's go ahead and just ask, what was bad about apple? Why is this not a floating point number? I know that seems like a silly question. It requires a silly answer. Why is it not a floating point number? Sorry? Yes? Don't be shy. Please, don't be shy. This is not a trick question. Come on. So shy, everybody. It's because it's got letters, and letters aren't numbers, right? Letters aren't numbers. So there's obvious. So if we actually like dig into that reason, some characters are valid characters, and some characters are not valid characters, right? When we do 9 plus 12, that plus is not a valid character. Make sense? So we can say, so what could we do with this? Well, what we like to do for this is kind of similar to what I did when I started. First thing first, when I write these Boolean functions that check if something is true or false, I always start out with the last line, which is my assumption. I'm going to assume everything, that it's always true or always false, and then try to disprove it or prove it, depending on it. In this one, it's easy to assume that it is a floating point number, and then prove that it isn't. Okay? By showing it violates some arbitrary rules. So we're going to do that return true as kind of our bottom line. Assume that it's a floating point number. Okay? Now, first rule, and probably the one that most of you would just focus on, and I would expect of you to write, is basically saying, oh, let's just make sure that it's that we're going to go through each letter and check to make sure each letter is a valid character. Right? For I in, so not for I, but for letter, let's call it C. For character C in text. For every character in the text. Okay. And we could do something like this. If C, don't write this down. Do not write this down. If C is equal to 0, or C is equal to 1, or C is equal to 2, or you get the idea, right? That's a terrible way to do it, right? It would take a while. We see this in another common problem I like to ask on exam 2. Hint, hint, nudge, nudge, wink, wink. A problem that requires you to count the number of vowels in a function. So let's go ahead and step by that for a second, just to complete aside here, right? Checking if something is a vowel, right? Just checking if some letter is a vowel. How would I check if some letter is a vowel, right? I could say if letter equals A, or letter equals E, or letter equals I, right? I could do that, but there's an easier way, a nicer way by using some built-in stuff with Python. And that's by writing out something like this. The list of vowels, the vowels are A, E, I, O, U. I can list them out, or I can put them in a string. I'll show you both. So both this, doing it like this, or like this, is perfectly valid. Although one is certainly easier to type, as evidenced by my issue typing right now. Whoops. See what I mean? And no, Y is not a vowel here. Okay. Right? Either of those work, right? Creating a sequence is all the vowels, right? And so, and we can just use a bit of our sequence knowledge here to basically ask a question. If letter not in vowels, which is actually really easy to read, right? If the letter I'm looking for is not in here, that's very easy to kind of evaluate true to false in kind of your head, right? Oh, is L in here? No, it is not. So we'll do return false. Oh my gosh, false. Return true, otherwise. Make sense? We could do an else statement, but we don't really need it. By default, we're just going to return true. So similarly, whoops, I'll just give you a second over here to look at it. Right here. And similarly, over here, we could write down a valid characters over here and write down, and this is even easier to type, right? It's always fun being able to do that. Just simply bring your hand across the keyboard. Okay? So those are the digits, right? In a floating point number. Those are what are valid, right? And then there's two other characters. One we may not actually think of. Technically, there's three other characters. There's the period, right? There's minus for telling if something is negative, and then you also have plus for telling if something is positive. But as I'll discuss, these have very specific use cases. For floating point numbers, right? Negative numbers, that minus sign can only appear at the beginning, right? But those are more advanced rules. So what we're going to do here is, rather than writing down each of these characters in a big if statement with ors, which would totally work, and you could have done that in the amount of time it took me to spiel on about this, okay? We could instead ask if C not in valid characters, because here we were just checking one letter. Here we're checking every character in the text and asking, hey, if any single one of them is not in the valid characters, return false. An important thing to understand about these false statements, right, sorry, about these return statements, is that they will stop a function. When a function's job is to do something or return something. As soon as it hits a return, it considers the job done. So for character in text, if character not invalid character is returned false, right? And then there's some other configuration, some other things we could go into. For instance, we could make sure to ask if if text dot count. There's other tests we could do to be even more strict. If text dot count a period is greater than 1, right? Things can't have more than one floating point, right? You can't have more than one period. Or, right? You can't have more than one decimal point in a number. And yes, I'm making a big statement over here. The same thing for a negative sign or a plus sign, right? You can't have that. You can't have more than one of those. You can only have one of those. Actually, technically, because of the way negative plus works, if the number of minus signs plus the number of plus signs is greater than 1, so if you have more than, right, that even gets even stricter. Return false. And so we can add on to this, but this is more than strict enough, I think, for the for what we're writing. And so now we can actually test our function, right? So let's run it. I'll do apple, banana, and then 5. Done. Let's go ahead and check it. A, C, period. Okay, so it accepted period because, right? Now, again, these are the kind of edge cases you would need in industrial strength programming, but for here, I think, at least for getting started with this homework, this is where we want to be, right? Okay. Now, as far as basically telling how many coins to make change for, this one's actually fairly straightforward when you think about it, right? We'll create a separate function called change, and we're going to pass it a number, okay? I think you pass in the dollar. Actually, I think what you're given is the dollar amount. So the first thing we need to do is change that number to cents by multiplying that number by 100, right? Make sense? We're going to multiply it by 100, and we're going to turn it into an integer. Just because that's going to make things easier for us, right? Because that's the way money works, right? We turn dollars into cents when we're working with coins. Now that we have this, there's basically 2 ways you can go about solving it. And in both ways, I would focus on quarters first. And just say, how many quarters can I make with this? Forget total coins, just think about quarters. The first way is division, right? If I have $2.05, then I can get 8 quarters out of that. Right? I'll have 5 cents left over, but that's a problem for later me, okay? So I can do division there, right? That's way number 1. Basically, how would you do that? You would use division, and then you use modular arithmetic to say how many coins I have left over of something, okay? So that's way number 1. Way number 2, which honestly, because I did more mathematically inclined stuff for my undergrad, I'm very partial to doing division and modular stuff. But the other way, which is perfectly acceptable for this one because we want you to get practice with while loops, is to use a while loop. And it looks something like this. While cents minus 25 is greater than 0. So while subtracting a quarter, while subtracting a quarter, while I can subtract a quarter, okay? While I can subtract a quarter from this amount. Greater than or equal to 0, yeah. Yeah, since minus 25 is greater than or equal to 0. So while I can subtract a quarter from this amount and still have coins left, then what I'm going to do is I'm going to keep a coins count. Coins plus equals 1, sorry, coins is equal to 0. And I'll say, okay, while I can subtract a quarter, do so. So we'll take out a quarter and say we took out 1 quarter. It's not asking us for a breakdown of quarters and dimes and all the other ones. We're just asking how many coins total. Quarters, nickels, dimes, pennies combined. Okay? And so we're basically saying, while I can subtract this out, do so. And believe it or not, this is basically the entirety of the program done. Because guess what? You just copy and paste this for all 3 other denominations, except you just change it. Okay. I will post this as an announcement. So if you're furiously trying to get this down, I do not want to have to pause here to simply continue on with this. If you did try the credit card stuff and decided to go with a more challenging one, good on you. My advice here for testing it is that there are certain, and you can go and check PayPal's documentation for this because PayPal's got this documented. There are certain credit card numbers that are set aside by credit card companies for testing purposes. And there's just a list of them, like credit card test numbers. You can look them up. They will, and credit card validator functions will bring them back as valid, even though if you try to pay with them, it will come back with a, you can't pay with this one. This one's not actually real. But these are meant to be specific ones to test to make sure you got the algorithm correct. Okay. Yes, I spent quite a bit of time on that, and that is fine. So I have, now as I mentioned, I pushed the due date on that back. It was due tomorrow, but I was talking with the TAs today, and so we pushed that back to Friday. If I need to push it back further, and the other one back further, I will. Because what I'm thinking of doing is I'm thinking of knocking Pig to being a in-class exercise or something, or possibly extra credit. And then what we'll do is that we will, I'll swap it out with a much lighter assignment on GitHub much earlier, which is just simply, and the GitHub assignment is very simple. It's like the first step in our final project, but it's very simple, which is create a GitHub account, upload it, fill out a form, upload it to your account. That's it. That's really what it is. And it is very simple. We just want to get that done with you sooner. But let's talk about Hurricane Tracker. This is the one where I feel like when we are done, that once you're done with this one, first you can call yourself a programmer, and you can actually show like people your program and be proud of it, because it's actually pretty cool. Okay. First, before I go over this giant's text, I'm just going to run this and show you what it looks like. When you demo it, this is what I expect to see for Lab 7. And that looks like a lot, right? And it's a bit hard to tell from this, but what we're looking at here is we are looking at the path of Hurricane Irma as it goes through with, and that color represents the category of the hurricane that it is, with numbers printed on screen. Now that looks terrifying, I'm sure. It took me about 3 hours to do this program, but most of those 3 hours were because I swapped longitude and latitude. Serious. It's actually, this program, when you are done with it, will go, wow, that was a lot easier than I thought it was. Okay, why? Well, it's because what this is. This is just Turtle. All this is Turtle. This is Turtle graphics. We have a bit of custom code that will background the window of your program with the Atlantic Basin and replace your turtle, the graphic of your turtle, with the with the symbol for a hurricane. And the rest of this is just simply a turtle function. What your turtle is doing is he's reading a file and going to the appropriate latitude and longitude. Also, we've already converted, and for sake of not driving you insane, we've converted the coordinate plane that you work with from being from like the center being 0, 0 to mapping out where the x and y would actually be the latitude and longitude. Or is it longitude and latitude? I'm serious here, right? We always say latitude, longitude, but which is which? So that's one of the things to just double check. And if you find that your turtle doesn't show up, just try swapping your x and y's. Okay? So we give you this giant big thing called starterfiles.txt. So you aren't starting from scratch here. And in fact, my favorite programs that I give students are not starting from scratch. So what we do over here is we go over here, we download it, and you want to save this wherever you go, wherever you're going to be working on it. And this is important. It's a zip file. Hopefully you've worked with zip files before. You've probably been asked to zip stuff. But basically a zip file is just a way to make the computer believe that an entire folder is one file. I mean, an entire folder is one file when you get right down to it, but we'll extract it. And here's our files, right? Starter files has the starter files folder, and I'm just going to drag that out. There we go. So starter files has 3 things in it. It has data, it has images, and it has irma.py. I'm going to go ahead and go Irma, and I'm going to go ahead and open this. Okay. We're going to go to desktop, and I'm going to just go and find it with name. Starter files. Okay, yeah. Irma.py, open it. Now, there's a couple of important things to understand when you're working with this one that we'll be going over this week in general. First off is that the folder setup is important because you got to be able to find the files, okay? And actually, that's pretty much it. The one important thing. Just you got to make sure that you've got to be able to find the files. Now, if you're working in VS, so for most of you working in idle, continue to work in idle. You'll have the easiest time if you do so. If, however, you decide to work with VS Code, okay, it's very important that you do the following. Okay, give me 1 second. Projector mute. Okay. So let me go ahead and close this folder. Okay, so when you open VS Code, you'll have something blank like this. Now, you'll be tempted to open up your file and run it if you're working in VS Code, and you're going to run into difficulties if you do that. Instead, what you need to do is do the following. Open folder. And then what we're going to do is we are going to go to desktop and go open, or to wherever you happen to save that starter folder, and open it up. And you'll notice that it has the 2 folders over here on the side plus the file. Yes, I trust the authors. Otherwise, it's not going to be able to see these 2 folders. Okay, otherwise it won't be aware that these things exist. So if you're working in VS Code and you're stuck, that's what you need to do. If you're working in idle, again, all you need to do, keep it simple. Just simply, if you're working idle, you can even have a simpler time. Just right-click on this and show more options or whatnot. And you should be able to edit with idle. Or, in this case, right, open up idle. And then go find wherever you put it. And that's the important thing. You have to know where you put it. When you download it, be deliberate where you put it. If it goes into your download folders, move it to somewhere outside your download folders where you're going to have an easy time accessing it. And just open it up. Okay? And what you want to do to test it is just hit the run. And if you see it blink and go away, great. That is where you need to be. You'll be like, oh no, it's blinking and going away. Something's wrong. No, it's fine. It found the file. So this is how you know, and this is what you'll get, and this part, this is what you'll get if something has gone horribly wrong, by the way. So if something has gone horribly wrong, I'll just copy this file. Let's say you download it from a friend, you download it from a friend or something, right? You ask your friend to send you their solution, and then you go and you open it up in idle to demo it. Right? It doesn't matter that this one isn't done yet. Right? I'll open up irma.py. I'll hit run. And it doesn't blink. It just pops up as a white screen, and you'll see I get a ton of errors. But specifically what I'm going to get is this couldn't open atlanticbasin.png, no such file or directory. A file not found error, as we call it, right? And this will happen if basically you're, so it happens one of two ways. One, you did not keep everything together. You didn't keep the folder together, right, of all the files that you download. Two, you downloaded it from, the internet. You already got it. You get a solution from someone else. Or three, which is the most understandable case, which is that the VS Code thing, where you have to open up the folder in VS Code rather than the file. Okay, and if that's the case, then that's not too much of an issue. So now that we've got that away, yes. You have to unzip it. Did you unzip it? Yeah, right-click on it, unzip it. So to right, you've got this file over here. Right, you download this zip file. Right, it's going to look like this thing, and it's going to say files.zip or something like that, or it's going to look like a zipped-up folder on Windows. Right-click, extract all. That's all you have to do to unzip a file. There will be something very similar verbiage on a Mac, although I think on a Mac, if you just double-click it, it will automatically unzip it for you. So, okay. It's going to be very similar. All right. So let's go over that giant verbiage here. It's essential that all work is done in irma.py, and the file structure that's present in the zip file is maintained so that irma.py can find the other files. If you do not know what this means, ask your TA, your professor, or your classmate. Demoing this assignment and getting an error due to a misplaced file will result in an instant zero without an appeal. Demoing it. So coming at me and asking a question about how to fix it, that's fine. But don't demo it, because it means you did not write your code, or at least did not learn how file works. And ever since I put this in, by the way, I have never happened to give it a zero out. But before that, I would constantly get students who would come and try to demo their program, and it would run, and they'd try to run it, and they'd have no idea why it won't work. Okay, I tell a lie. I have one student who demoed that and got a zero, and violated this one and got his instance zero. But that's also the same student who's the reason I have why I have the 2 weeks clause in the syllabus. It's that same student. It's also the same student who showed up, who tried to demo everything over Zoom shirtless. So, it's a, it's just a mess. Just a mess. Okay. All right, so this file, so let's go over what this file does. It does quite a bit for you, first over here. Okay, let's package this up. It's got 4 portions over here. First off, if you're coming from another program, this is your first time programming, this is magic. Just ignore that. This is the black magic. That's fine. Just don't touch this part. Okay. You can erase this part and just do IRMA, but you just don't need it. Second, this def IRMA. This is where you're going to be working. That's where you got everything else. You can read it. Don't need to touch it. Don't need to touch it at all. All your code's going to go in here. Okay. I'll go over this in just a second. Next part, IRMA setup is the stuff that does all the hard stuff for you automatically. So we see we've already imported Turtle for you, okay? And then what this does, let's read the comment over here, the documentation. creates the turtle and screen with the map background and the coordinate system set to match latitude and longitude. Pretty self-explanatory there, but I will go through it. First, it says import tkinter. Tkinter is the library that turtles are built on. Okay, it's a very powerful graphics library for building windows and stuff. Turtle.setup, that just simply sets up how big the window is going to be. So just like we can get the turtle to draw on the screen, we can actually get the screen itself, the window itself. It's not something you'll need to use, even though you will have access to it, but you'll see that, hey, turtle.screen gives you the window, and then you can change the title of that to be whatever you want by using window.title, and they changed it to Hurricane Irma. That's why when we run this program, you'll see it says, it pops up very quickly, but you'll see it says Hurricane Irma before it exits out. Kludge to get the map shown as a background image. So this is just figuring it out. And then set world coordinates, this is what changes it. This is how they figured out how to change the thing from latitude to from XY to latitude, longitude. Okay. Then here we go. Map background image is equal to a tkinter photo file. And then images / Atlantic Basin.png. And because of the way that time is going, I'll focus tomorrow. I will focus very briefly on file reading today, but I'm going to go in a lot more depth on Thursday. Okay, much more like a traditional lecture. Okay, we create our it gives us a turtle. This changes the shape to the hurricane image, and then we get back the turtle, the window, and the map background image. I don't know why we get these two things back. All you need is T. T is our Bob here, okay? And then you just tell T to do stuff. Now, let me go ahead and just do two things here to kind of show this. T.done. First, I'm going to do T.done. And this is important, especially if you're not working in idle. If you're working in idle, don't worry about this. Not T.done. It's not T.done, it is turtle.done. If you're not working in idle, this is kind of useful, because if you are not working in idle, it'll just close when you run it, when it's done running. When there's no more code to run, it'll just close. Turtle.done will say, we're going to keep this open until you actually say you're done with it. So now that I'm running with it, you can see here, it's open, right? Now, next, let's actually get this turtle on screen, shall we? Right now, he's starting off at 0, 0. Okay, let's go to Google Maps for a second. New private window. Okay, and let's go ahead and just give me a second. Maps. Google.com. Zoop. Okay, so let's go to latitude. We can do latitude, longitude, I think. 0, 0. So 0 degrees north, 0 degrees east. That's right here. That's not on our map. But that's where our turtle is right now, because the turtle starts where? 0, 0. So, by the way, if I were to instead be like 50 degrees, if it was 50, 0, we'd be a bit further to the north. So our first, quite a bit further in fact, our first coordinate is going to be latitude. So in our normal latitude longitude system, latitude is essentially our y coordinate. So we're going to need to do that. So let's go ahead and move our turtle somewhere interesting. Let's go to Disney World. Okay, Disney World. Okay. Disney World amusement park, that's right here. That's on our map. Okay.
Are you able to control where the turtle starts in the program?
I think you probably can, but we're just going to move it. We're just going to move it there. So let's go ahead and...
Am I able to choose where it starts? Like when I do this lab?
Well, let me do it this way though. Walt Disney World Lat Lawn. Okay, latitude, longitude. Okay. Okay, so its latitude and longitude are this. Now, with the turtle function, T is our turtle, it has access to something called to go to, and that's what we're going to be using this assignment to do this program. Go to goes to a specific xy coordinate. So we know that, so let's go ahead. We have our latitude, and we have our longitude. And that's where it is. And if we tell turtle to go there, it will go there. Inconsistent use of tabs and spaces. Oops, okay. And it doesn't go anywhere. Well, because again, as I said, latitude, longitude. Latitude is north-south. So this should be the second coordinate. Right? So latitude is our y coordinate. And so now if we tell it to go there, it just goes straight there. So that's where our turtle is. Just telling it to, I can tell it to go anywhere basically on this eastern seaboard of the United States, and I'll be able to go there, given the latitude and longitude. Okay? Now, going back to what this problem is actually supposed to do, right? What we're supposed to do is trace out the path of Hurricane Irma. Now, we could do any other hurricane, but I just happen to have the data for Irma among others. What other? And I do have quite a few number of things. So let's go ahead and look at the other files we have. We have our images folder, which has two very familiar images in it, right? And our data folder, which has a bunch of CSV files. CSV files stand for comma separated values. And this is a good place as any to start our discussion of files on computers. There are two types of files on computers. There are text files and binary files. Broadly speaking, you can have other categorizations, but broadly speaking, you have two types, text files and binary files. A text file is something that can easily be read by a human and a computer easily and natively. So .txt files, .csv files, .py files, any programming files, those are text files. They can be read by a text editor. Ironically, what did I not list? .doc, .pdf, those are binary files. Why? If I open them up in a text editor, right? So I'll have VS Code open. Let's go ahead and, yeah, why not? Let's go ahead and open up and see what that looks like. I have this PDF file over here. I'm not sure what it is anymore, but let's go ahead and if I drag it into here, oh, it did not like that. Oh, give me an error. The file, it does not look like a text file, or the text file encoding is not supported, right? If I try to open up a PDF file in a text editor, it just kind of barfs.
How do you get like this screen of the world map? Because as soon as I run it, like shows the screen of the world map for like a second and just turns.
This line over here.
Which line?
This line, add this line, turtle.done.
Okay.
Just add that line, and it will not disappear. Or just, make the program and it won't disappear until it's done. Okay, but here you can see that there's a bunch of like encoding in here, and then there's a ton of stuff that is not meant to be read by human. It's meant to be read by a computer to then be figured out to render into text of some kind. Okay? So, again, what we've got here is our way of doing that. Sorry. So here we've got basically these two types of files. CSV files are text files. They're basically the text equivalent of our of Excel spreadsheets. let's go ahead and open one up and see what it looks like. In fact, by default, it would open in Excel, but I'm just going to open it up so you can see the text. And we see over here we've got a couple of things. We've got date, time, longitude, latitude, wind, and pressure. Of these fields, you really only need three of them. You need three of them. Okay? You need the latitude and longitude to tell it where it's going to be, right? You can see that this is tracking Hurricane Irma at different times, right? And it says at September 6th at 15 past midnight, it was at this point. It was at north 17.2 and west 60.5. And then it had a wind speed of 185 and a barometric pressure of I'm not sure what unit that one is, but it's 916, right? So this is just simply timestamp data. So you need only three parts of this. You need the latitude and longitude to do the first part, which is just simply saying, okay, we want Irma to go to these spots. I want it to go here, then here, then here, then here, then here. But I don't want to have to copy out like these lines by lines, and just put them into my file. I want to be able to read this file and, go line by line to get this stuff out of it. And we will be going into detail on how to do that on Thursday, because again, we're running limited on time here. And then the other part where you notice that basically the bar was being colored, right? That's determined on the strength of the hurricane. Hurricanes have different categories, right? From anywhere from being a tropical depression to being a Category 5 hurricane, and that depends on the wind speed. What is that? I don't know off the top of my head. You're going to figure out the same way I do, which is looking it up on the NHS website, or not NHS, but whatever hurricane services are. What is our hurricane websites anyway? But by using basically the information available on the internet. Is it National Hurricane Service? What is NHS? National, I gotta know now. Hurricane, is it NWS because it's National Weather Service? NHC.NOAA, NOAA, that's it, NOAA. Right. Jerry. It's always a Jerry. Okay. Anyway, so you'll see that basically the wind will tell you what strength it is, and depending on and once you've got your turtle moving, that's when I would talk about changing the color and the thickness of it, okay? To match where you're on. Okay? Be sure to read the entire file, but once you get the turtle moving, that's pretty much it. Okay? So what do we need to do to read a file? So, in general, what we do, in general, reading a file in other languages is honestly a bit of a pain in the butt. Okay? In other programming languages. In Java, it looks something along the lines of having to do this. First off, you would have to have a file like this, public class file reading example. Okay, just to kind of show you how it works, right? Okay. And then to run something, you have to do something like this. Public static void main, okay, string args. And this is why I hate teaching Java as an intro language. It's okay, but basically you have to point at this magic statement and say, don't worry about this, we'll figure out what it is later, right? Well, you just got to memorize it for now. Okay, and then if I want to read something, first off, I would have to make sure that I import java.util.scanner to make sure I could read, and then I would say something along the lines of scanner is equal to new scanner, and rather than doing system.in like we would have done the rest of the semester, I would say something like new file, example.txt, and then that would give me a warning, and I'd have to actually say try, put that around, and then I catch exception E, which would be completely new. And I'd say, let's figure out how to handle that later. And then now that we've opened the file, now that we've got the file, I would basically say something along the lines of while scanner, this would be actually the easy part, scanner dot has next line while there is a next line to read. Right. Scanner dot next line to read it. Oh, and I would have to store it somewhere. String line, and then I would do what I want with that line. So it's a whole lot over there to just kind of read it. Okay. Let's go ahead and put this into onto my desktop, and I'm going to call this file. I called it file reading example dot Java. Right, I'm not going to bother running it. It's not the point of this. And so here's how we read a Python file in Python, any text file, including source code. Let's create a new file. So I'm going to so first off, you want to put it, for right now, you'd want to put it in the same you'll want to create a test file like the one I just created, or some text file to read, maybe a different Python file, okay? And we'll go over like an example, and I'll give you an example file to download next class. It will be a CSV of Pokemon, okay? So, and their stats, and I'll give that to you so you can play around with it. And here's what we do. I'm going to go ahead. So if you're not getting this part, I don't have time to go around and help you fix it. That's all dedicated for Thursday. We're going to do that all on Thursday, helping you make sure you understand how this works on Thursday. But here's what we do. I'm going to just call file reading.py. It's in the same folder, and I'm going to put it on the desktop so it's in the same place as the file I want to read, which is that Java file I just wrote. Okay, here's how you open up a file to read in in Python. Data is equal to open, and then give it the file name. File read example.java, which is that Java file I just wrote. And that's it. It's open for reading now. If you can't find it because the file doesn't exist, you'll get an error like this, right? But because I created this file and it's on my desktop, I can read it. I can hit F5, boom, it's there. Okay. And then to actually read it line by line, I do something like this. Actually, this is the moment I actually kind of fell in love with Python as much as you can fall in love with the language, where I'm like, okay, how do I read this now? Don't tell me it's this easy. It is that easy, actually. Print, oh right, print line. And, oh, look at that. There's the Java code I just wrote. Right? So to read something, it's very simple. If you want to read text, if you want to read a file, line by line, you find the file, you open it up, and store this in, and this creates a pointer or a reference to the file. Here, let me show you what I mean. Print data, right? If I try printing out the data, you'll see that it says a text IO wrapper with a bunch of other stuff you don't need to know. Well, the name, that makes pretty easy stuff. Then it has mode, R. Any guesses what mode R means? This one's fairly, it's the fairly obvious if you think about it for a second. R for, yes?
Read.
R for read, yes. The other valid modes are W for write, exactly. W for write. The last one's less obvious. It's A for append. Okay, read where you want to read a file. Then you can also do W. If you open a file with W, you're basically overwriting a file. So that's very useful if every time you want to run a program, you want to overwrite what you did each time, because you're starting from scratch. And then A append says we're going to add on to the end of this file. Okay. Most of this class whenever we deal with file reading is going to be dealing with this stuff. So where is the target, I guess I should say. So because we're just starting with file reading, it's probably a good idea to know where you're going to end up with this. An exam question I gave years ago, and now is a practice exam questions, okay, was something along the lines of pretend we have a file called temperatures.csv, which is the temperature. Here's it has the day, the high, and the low for Philadelphia. Okay, and I show you the file format, right? The example file format of how that would look. Write a program that would tell me which day had the hottest high and which day had the lowest low, right? And then for the third one, I wanted to know what the average high temperature was. That's basically what I ask in for these kind of file reading questions. On the final exam, one of the questions that you can choose is a file reading question, and it basically asks you, hey, which of these, this is what I've used in the previous year, so I'll find a different one this year. But in previous years, what I've used is, hey, here's a list of animals, here's the mass of their brain, here's the mass of their body. Which animal has the biggest brain-body mass? Which in other words is asking, brain-body ratio, which basically asks you divide the brain by the body mass and find out which one is the biggest, right? So, and the way all these problems work is you open the file, you read it line by line, and so you get each line, and then you ask, okay, now that I've got this line, well, if it's in a format like this, where all the things are separated by value, by commas, right? How do I split it up to be able to read? And that's what we're going to talk about next week. Now, the last thing I want to tell you before you go is that opening this file in Irma is going to be a bit tricky, because, right, we want to open up the file that's called irma.csv. And if we try to do that, data is equal to open, and I'll go over this next time in more detail, but I want to leave this with you because otherwise some of the more ambitious students are going to try this and they're going to run into a roadblock. Open irma.csv, and you're going to try to open it, and if you try to do that, you'll get a file not found exception. It says you can't find it, but notice that like when we were opening up the pictures, it said images/, right? Remember, if we look at the file structure of our folder over here, we've got images, and it has there's a folder in it. Data. So if we want to look in our CSV files inside the data folder. So if we want to look inside the data folder, what we type is data/irma.csv. And now, as you can see, it opened it up. We didn't do anything with it, but it didn't error out, right? So now you can actually, so to get into it, you have to open data/irma.csv. And that's why you have to keep the data where it is, or keep the file structure as it is. You can move the entire folder around as long as you're moving the whole folder. Make sense? Right? I can take this off my desktop, right, and I can move it somewhere else, and that doesn't matter. Make sense? Okay. Now, the plan for again on Thursday, what we're going to do is I'm going to have I'll announce a URL. I'll give out a URL, I'll send it out as an announcement during class, and that URL will contain Pokemon. Okay, it will contain the stats for Pokemon. I don't think it's the most recent gen. I think it was valid up through Sword Shield, but we can do things. But because it's a CSV file, we'll be able to read through it. Okay, doesn't matter if you don't know Pokemon or not, although you're totally missing out.
What's your favorite gen?
What?
What's your favorite generation?
Whatever the current one is, it's always. I'm not particular. I'm easy to pick. I don't have a favorite generation, is what I'm saying. I enjoy playing whatever. I did play Black and White. I probably enjoyed Black and White the most because I didn't realize its gimmick until way too late, which was that all the Pokemon were new Pokemon. And that was that. And once I realized that, that was really exciting. I loved that. It was really nice. But I've been playing since Red. I've been playing since Pokemon Red. You know, so. Yeah, so I've been playing for a while. It was absurd. I had an entire, thanks to the missing no glitch, I had an entire team of over level 100 Mewtwo's. It was absurd. No, again, when you've got 6 Mewtwo's, you really don't need
6 Mewtwo?
Well, in Red, it was the missing no glitch, if you know what I mean. Okay, all right. So let me stop the recording here before.